Most gardeners throw grass clippings into a pile, walk away, and come back weeks later hoping for compost. What they find instead is a matted, slimy, nitrogen-saturated layer that smells faintly of ammonia and looks nothing like the dark crumbly humus they were expecting. The process of grass clippings becoming true humus is not mysterious, but it is specific. It moves through identifiable biological phases with measurable chemical changes at each stage, and understanding those phases turns a guessing game into a trackable process with predictable outcomes. We tracked it from fresh clipping to finished humus, and what the data showed changed how we manage every organic input in this garden. If this kind of detailed, evidence-based gardening content is what you come here for, subscribe and leave a comment telling us what organic material you are currently composting. Your engagement helps this channel reach more gardeners who want to understand their soil rather than just feed it. Now let us walk through what we actually observed. The first thing you need before you begin tracking decomposition is a way to measure what is changing in the soil environment as the process progresses. We used the Nudist soil test kit, link is in the description, and it became the most important tool in this entire experiment. The kit tests 4 parameters: pH, nitrogen, phosphorus, and potassium, with 40 individual tests per kit providing professional level accuracy at home garden scale. The reason all 4 parameters matter during grass clipping decomposition specifically is that decomposition is not a single event, it is a biological cascade that shifts each of these values in sequence as different microbial populations dominate different phases. Tracking pH alone tells you part of the story. Tracking all 4 parameters tells you exactly where in the decomposition sequence your pile is and what the soil beneath it is receiving at any given moment. For a topic about measuring rather than guessing, this kit is precisely the right tool. Fresh grass clippings are approximately 80% water by weight, which means a pile that looks substantial loses most of its volume within the first 72 hours as cellular moisture releases during initial microbial colonization. The dry matter that remains is primarily cellulose, hemicellulose, and the proteins that give grass its high nitrogen content, a carbon-to-nitrogen ratio of approximately 15 to 20 to 1, significantly below the 25 to 30 to 1 ratio that optimal composting requires. Our Nudist kit readings at day 3 showed a significant pH drop from the initial near-neutral reading of approximately 6.8 to 5.9, a measurable acidification driven by the organic acids produced during mesophilic bacterial metabolism. Nitrogen levels in the surrounding soil showed a modest initial increase as bacterial activity began releasing soluble nitrogen from the decomposing grass tissue. This is the phase most gardeners observe as the pile heating and beginning to shrink, and it is the phase most commonly interpreted as composting in progress when in fact it represents only the first of 4 distinct biological transitions the material must complete before it qualifies as humus. The thermophilic phase, temperatures above 45 degrees Celsius driven by the metabolic heat of thermophilic bacterial populations that replace mesophilic bacteria as temperature rises, is where the structural carbon compounds in grass clippings begin to break down. Cellulose decomposition accelerates significantly above 50 degrees Celsius as the thermophilic cellulolytic bacteria achieve their optimal metabolic rate. The volume of the pile drops dramatically, typically by 40 to 60% of original volume, during this phase as carbon literally leaves the pile as carbon dioxide through microbial respiration. Our pH readings during the thermophilic phase showed a return toward neutral as the organic acids of the mesophilic phase were consumed by the thermophilic community. Phosphorus availability in the surrounding soil began measurable increases at this stage as bacterial cell turnover released the phosphorus stored in bacterial biomass into plant-available forms. The cooling phase that follows peak thermophilic activity brings a shift in microbial community composition that most composting guides treat as the end of the interesting biology, but it is actually where the most valuable transformation happens. As the pile cools below 45 degrees Celsius, fungal populations that were suppressed by the heat of the thermophilic phase begin to colonize the structurally simplified but not yet humified material. Fungal decomposition is the process responsible for the final breakdown of the lignin compounds that bacteria cannot efficiently process, the complex aromatic polymers that give plant cell walls their structural rigidity and that are the last major organic component to be transformed into humus. Our Nudist readings during the fungal phase showed the most dramatic potassium increase of the entire process. Fungal cell turnover releases potassium-rich compounds that represent a significant fertility contribution to the surrounding soil. This is the stage where the white mycelial threads become visible throughout the pile material and the earthy smell of active decomposition, petrichor, becomes most intense. True humus, the stable, dark, aromatic organic matter fraction that represents the fully humified end product of decomposition, begins forming during the fungal phase and continues developing through the final maturation phase that follows. Humus is not decomposed organic matter in the sense of matter that is simply broken down. It is a new class of chemical compounds, humic acids, fulvic acids, and humans, produced through the microbial synthesis of complex aromatic molecules from the building blocks of decomposed plant tissue. Our final nudist readings, taken at the point where visual, tactile, and olfactory characteristics confirmed humus formation, showed pH stabilized between 6.5 and 7, nitrogen in a form that indicated stable organic nitrogen rather than the volatile ammonium of early decomposition, and balanced phosphorus and potassium levels that reflected the complete release of nutrients locked in the original grass tissue. The nudist kit gave us the data that turned observation into understanding. Link is in the description.